Okay, today we are going to talk about three variable systems. So like we said before, if we have two equations, then we can have two unknowns. And here, if we have three unknowns, which we call variables, then which looks something like ax plus by plus cz equals d, that is a three variable equation. And if I were to need to solve for x, y, and z, I would need three equations to do that. Now a solution, if you recall, of a two variable, two equation system is a point. It has an x and a y. And we call that an ordered pair. Well, here we will call it an ordered triple. And that's x, y, and z. Okay, so the first thing I want to look at is I want you to verify that the ordered triple is or is not a solution. 3, -1, -5. So I want to verify that this ordered triple is or is not a solution. And my system is x plus y plus z equals -3 and 2x minus 3y plus 6z equals -21 and -3x plus 5y equals -14. So if we think back how we verified that a point was a solution in the past, we had to test this point, or in this case an ordered triple, in all three of these equations. So this is one of the first things I'm going to check. I want you to show me how you plug in x, y, z, and I'll write that down. It always goes in alphabetical order. X, y, z does hold true for all three of these equations individually. So you'll have three little lines or sets of work to show that. Okay? The next problem is just a solve. We have x plus 3y plus 2z equals 1. 5y plus z equals -3. And z equals 2. Now on a problem like this, we call this something you can use back substitution. And the reason I say that is because if you start, we already know what z equals. And if we then plug this z into this equation that only has two variables, you will see you can then solve for y. And once we have y, we can then back substitute again. We know z is 2, we will find y out, and we can solve for x. So let's go ahead and try that. The first thing I'm going to do is z is 2. So I have, using this equation, 5y plus z is 2 equals -3. So now we subtract 2 from both sides. 5y equals -5. Y then equals -1. So now I know two pieces of information. I need that third piece. So now I'm going to back substitute these two pieces into the original. So I have x plus 3, I'm just writing right from here, y is -1 plus 2 times z is 2 equals 1. So 3 times -1 is -3 plus 4 equals 1. X minus 3 plus 4 is plus 1 equals 1. So x equals 0. And the most important thing is, do not forget how to write your final answer is an ordered triple. X, Y, Z. Zero, -1, 2. Okay, and if we verify that, we can plug those 3 points into all of these equations and it would work. So you can go ahead and check that on your own if you'd like. Okay, so what happens if we have a problem that doesn't look to be so simple in a back substitution format? So let's look at x plus 5z equals -6 plus y, 3x plus 3y equals 10 plus z, x plus 3y plus 2z equals 5. And I know that sounds like a lot, so take a moment, pause it if you need to. Remember, the key to using these videos is to pause when needed and get that copied down. Now the first thing you'll see is we've got stuff happening on both sides of the equal sign. We do need to take care of that. So what I'm going to do is I'm going to rewrite each equation in order. X, y, z equals a number. So we have an x, a y, a z, and equals a number. That's what these have to look like in order for us to set this up. Okay, so we have x. Now I'm going to move this y over, minus y. Now I have my z plus 5z, that's a z up there, equals negative 6. Okay, now I have 3x. Now I need my y plus 3y. Now I'm going to move z over, minus z equals 10. And this last equation is happy the way it is, plus 3y plus 2z equals 5. So what I need to do now, and this is really important to keep yourself organized, I'm going to go through and label each of these equations. So that's E1, E2, and E3. That's equation 1, equation 2, and equation 3. Because the purpose of this now is to take two of these equations, any two you choose, and eliminate one of the variables. So if I look, I can choose equation 1 and 3 and multiply 1 by a negative and eliminate x's. I have some choices. I could eliminate y's by choosing equation 2 and 3 and multiplying one of those by a negative. And z's, nothing looks so simple. Well, I have a 2z here, I have a negative z, so I could multiply this by 2. So let's just go right from the first thought, and we'll do E1 and E3. So I write E1 and E3. Those are the two equations I'm going to use. Now if I want this to be my negative, I'm going to write negative 1 times E1. So here's where you're telling yourself and me what you're doing, and now here's where you're going to do it. So I'm going to multiply by a negative. So I have negative x, positive y, minus 5z equals positive 6. Okay? And now E3, we're just going to leave the way it is. X, so you just recopy. Again, pause it if you need to. But now what we can do is we can use our linear combinations or our elimination, which we just learned, to cancel. So the x's will cancel. I have 1y plus 3y is 4y. Negative 5z plus 2z is negative 3z equals 11. So now this is some new equation. So I'm going to call this E4 and put a box around it. Because it didn't help me get anywhere, but I did eliminate x and I have a new equation. So now I need to go back to the beginning. I need to choose two equations. One of them has to be E2 because I haven't used it yet, and get rid of the same variable. So I'd have to use E2, and I have to get rid of x. Well, E2 is 3x plus 3y minus z equals 10. Now, I can use either E1 or E3 and just multiply by negative 3. So I'm going to go ahead, let's just use E3. And because I have a 3x here and I need this to be opposite, I'm going to multiply negative 3 times E3. So I have negative 3x minus 9y minus 6z equals negative 3 times 5 is negative 15. Now please pause this, re-watch it, write it down one time, watch it another time. This is a tricky little concept, but it's kind of like a puzzle, and it's not too tough once you get the hang of it. So now I add. X's cancel. 3y minus 9y is negative 6y. Negative 1z minus 6z is negative 7z equals negative 5. So this new equation we're going to call E5. And now that I have E4 and E5, and they both have the same variables, I can go ahead and eliminate one of them just like I normally would. So I'm going to eliminate y's. So I'm going to multiply E4, the lowest number I can get them to, or any number. Let's just do the easiest way. And any number I can get them to is 24 if I multiply them together. If you'd like to multiply them to get 12, that will work as well. It doesn't matter. So say we want to multiply them to get 12. I would have to multiply E4 times 3 and E5 times 2. So I'm going to go ahead and multiply that. 8y, whoops, excuse me. 12y, I'm multiplying E4 times 3 minus 9z equals 33. And now I'm going to multiply E5 times 2. Negative 12y minus 14z equals negative 10. Add them up, cancel. Negative 9 and negative 14 make negative 23. Z equals positive 23. So z equals negative 1. Put a box around that so you don't lose it. And now we're going to go back to plug it in here, and we have 4y minus 3 times negative 1 equals 11. 4y, negative times a negative is a positive 3 equals 11. 4y equals 8, y equals 2. So there's another variable. And now I have two pieces of information. I can go back to E1, E2, or E3 to plug those in. So I'm going to use E1 right here. And I have x minus y, and we said y is 2, plus 5 times z is negative 1 equals negative 6. So x minus 2, 5 times negative 1 is minus 5 equals negative 6. Minus 7 equals negative 6. Add 7 to both sides, x equals 1. Whoops. So there you have the final variable, and now you go ahead and write it as an ordered triple. X, y, z. And that is the final answer. You will see one of these longer problems on a test, but just so you don't panic, you won't do anything more than a 3 variable by hand. Anything after that will be done with a calculator and using technology. So this is the end of this lesson. This last problem was long. Please watch it again and possibly again and make sure that you kind of understand the concept. So the goal, again, let's recap. Go from your 3 originals, choose one variable you want to get rid of. We chose x. We got rid of it using E1 and E3. Now we got rid of it using E2 and E3. Obviously, one of the equations is used twice, but just make sure all 3 equations are used. We get E4 and E5, and now you're back to problems like you've been doing. Solve for y and z. Once you've done that, go back to any original, and plug it in to find the last variable. Please come see me if you have questions. I'm more than happy to help.